Okay, so we're going to finish up lesson 4.4 of our graphing rational functions in our pre-calculus book. And so we're going to analyze functions algebraically so we can find the vertical asymptotes, holes, and intercepts. Determine end behavior, so we're going to look at the degree of the numerator and the degree of the denominator. So we're going to be looking at the terms with the highest degree in both numerator and denominator to determine whether we have a horizontal asymptote or whether we have a slant or parabolic asymptote. And then we are going to graph it. So first of all, we're going to start looking at this function here, y equals x minus 1 over x squared minus x minus 6. And you can see here that I have factored this function so that we can use that information to find all of those specifics for our graphing. So first of all, we're going to look at the zeros. And a reminder of zeros are where the numerator is equal to 0. So in this case, that would be at positive 1. And our y-intercept is when x equals 0. And so really, we only need to look at our constants. And so we have constants of negative 1 and negative 6. And so that would give us a y-intercept of 1/6. Next, we'll look at our vertical asymptotes. And remember, vertical asymptotes are when the denominator is equal to 0. And the denominator is equal to 0 at here at positive 3 and at negative 2. And so we'll say that x equals 3 and x equals negative 2. Reminder, vertical asymptotes are always lines. Okay. So then we'll look at, for our end behavior, we're going to look at the degree of the numerator and the denominator. So the degree of the numerator is 1. We have x to the first power. The degree of the denominator here is going to be x squared. So if we look at those two, we will have x over x squared, which just simplifies to 1 over x. And so if we have really, really large values of x for end behavior, then that number is going to get closer and closer to 0. So we have a horizontal asymptote. At y equals 0. All right, so we're going to go ahead and graph this now. Then we've got the important information we need, so we'll graph it. So we'll put our 0 in here first, and that's at 1. So I'll put a point at x equals 1. And we'll save our y-intercept just for a minute. And our vertical asymptote at 3. So we're going to have a vertical line at x equals 3. And another one at x equals negative 2. And what these, because we use them as dotted lines, because they really don't exist, but we're showing them as boundaries for our graphing. And then we have a horizontal asymptote y equals 0. Well, you'll notice that we also have a 0 there. And when we're talking about our horizontal asymptote, it's end behavior. So it's okay to have a 0 there also because we're really talking about when x gets really large or really small. So that doesn't affect us. So that 0 is going to be okay. Now, when we're talking about graphing this here, right, we need to focus on the area. We're going to focus this area in here between the asymptotes first in this case. And since we have the 0 at 1, we know the graph has to go through that line. And we also know that we have a y-intercept here at positive 1/6. So this graph is going to have to be affected by the vertical asymptotes and that 0. So this graph is actually going to go, it's going to look like this in that area. Okay. Because it goes through the 0, it goes through the vertical asymptote, or the y-intercept. But these vertical asymptotes, they're boundaries, so I can't go to the left or right of that. I have to stay between it. So we are going to then draw a line then that goes through them, but does not cross the vertical asymptotes. Now the other thing is that now, since we're up here at positive infinity on this side of the vertical asymptote, that means on the other side of the vertical asymptote, on the left side, our graph is going to be over here. And since it can't cross the asymptotes, it's going to look like this here between them. And then over here, since it goes to negative infinity, that means it's going to come up here to positive infinity, and it's got to stay in the boundary of this asymptote. So it's going to look like that. So what I'm going to do is I'm going to actually erase this line, and I'm going to draw the graph here. Oh, oh come on. And there. All right, well, I'm going to draw it in, I guess. So we're going to go here, and like we had it here, and up here. All right. Okay, so there we go. There's one example. Let's look at another one. Down here we have a second example we're going to look at. And so we are going to, here we have a cubic function in the numerator and a quadratic in the denominator. And so when we get to our end behavior, those are important that we're going to be looking at. You can see that I've already factored this, so we can find our zeros and our asymptotes easily. So here we have zeros at -2, +1, +3. Remember, that's where the numerator is equal to 0. Okay? -2, +1, +3. Our y-intercept is the constant. So here we have a constant of 6 in the numerator, 2 in the denominator. So when I divide 6 divided by 2, I get 3. And then we'll look at our vertical asymptotes. Now you notice here we have 2 zeros in the denominator, one at -2 and one at -1. So that means we could have x equals -2 and x equals -1 for our vertical asymptotes. Now there's only one problem here. We have a 0 at -2 and a vertical asymptote at -2. Well, that can't happen. So since we've got this common factor in the numerator and the denominator, that means we're going to have a whole then at that x value of -2. So we can't have a vertical asymptote and a 0, so that creates a hole because we have that common factor. Now the last thing we have to look at before we graph it is our end behavior. And in this case we have our numerator is degree 3 and our denominator is degree 2. Since the numerator is 1 larger, that means we're going to have a slant or oblique asymptote. And so what we're going to do then is we're going to ignore this part here, and we're just going to focus on, to find this asymptote then, we're just going to focus on this part here, x minus 1 times the quantity x minus 3 and x plus 1. And so when we focus on that, we have x squared minus 4x plus 3 in the numerator when I multiply, and still x plus 1 in the denominator. So we're going to use long division, or synthetic division then, to find the equation of our asymptote. So we put in -1 and 1, -4 and 3. Bring down our 1. -1 times 1 is -1, so we get -5. And multiply them, we get 5, so we get 8. The thing is, though, is that we don't care about the remainder. We just want this part right here, which gives us x minus 5. Y equals x minus 5. Okay, so now we got all the information, we can graph it. We'll start by graphing our zeros of 1 and 3. And we have a y-intercept of 3. We'll save that one just for a minute. And we have vertical asymptote at -1. So we'll draw that line here. And then we're going to have a slant asymptote at y equals x minus 5. And so I'm going to go ahead and before I finish my graph, I'm going to put this in here first. Okay? And then we're going to look at our hole after that. So we have a hole, says at -2. So what I'm going to do is I'm going to put -2 in here for x, so I can find the y value, so I know exactly where that hole is at. And so we take -2 squared times -2 plus 3 divided by -2 plus 1. So in our numerator we get 4 plus 8 plus 3 is 15, and over -1. So that means we have a hole at the point -2, -15. So when I graph this, I'm going to put a hole right here at -2, -15. So when I draw the graph now, that means that because we have this asymptote here, we have our slant asymptote, that means the graph's got to come along here, come up, go down through the hole, and then down along the vertical asymptote. Now remember, we have to, since we came to -infinity here, we got to come up here to +infinity, and we draw our graph. We come down through 3, our y-intercept, hit our zeros, and then back up there. And make sure you do put arrows along your graph. And that would be graphing rational